In this video, we're going to be looking at the first derivative test for finding extrema. Alright, so what's the objective of this video? State the purpose of the first derivative test. Now, what that is saying is that the first derivative test can do multiple things. Alright, so it has a variety of things that it can do, but the ultimate goal is to find the extrema. Alright, so that's what the second objective is. Apply the first derivative test to find the extrema of a function. Okay, so here it is. Let's look at the formal statement. Suppose that C is a critical point of a continuous function f, and that f is differentiable at every point in some interval containing C, except possibly at C itself. Moving from left to right on this interval, if f prime changes from, if my slope changes from negative to positive at C, then we're going to have a local minimum. So for those of you that are visual, what does it mean when my slope changes from negative to positive? It's going to be from negative to positive. That means that I'm going to have a minimum. The second statement says if f prime changes from positive to negative, that means I'm going to go from positive slope to negative slope, then I'm going to obtain a maximum. All right. Now, what happens if there's no change in the sign? Then there will not be any extrema. In other words, if I'm going up and then it becomes slope of 0 and then I continue going back up, this right here, even though it has a slope of 0, it's a critical point, it is not going to be considered a max or a min. That's the first derivative test for extrema. So what you need to understand is the first derivative test it's broken down into 8 steps. All right. The first one is find the derivative. Okay. Set the derivative equal to 0. And then when you solve it, guess what we get? Critical points. So in reality, the first 3 steps here is find CPs. So on the exam, if I was to ask you, find the critical points for me, you could do the first 3 steps of the first derivative test and you're done. Okay? The fourth step here is draw a number line with a critical point. So I'm going to draw a number line here, and I'm going to put a CP here, and I'm going to put a CP here, and I'm going to put a CP here. So let's pretend this function has 3 CPs, right? And what we're going to do for step 5 is we're going to pick numbers in this interval. We're going to pick a number here, we're going to pick a number here, but we're not going to pick the CPs. And we're going to pick a number here, and we're going to pick a number there. And when I have those numbers, we're going to substitute them into the first derivative test. Now, what happens if I take a number and I plug it back into the original function? Let's say I plug it back to f of x. That's going to give me the y value. I don't care about the y value. I care whether it's positive or negative slope. So I'm going to be plugging it into the first derivative. Now, if I plug it in and I get positive, that means that the function is increasing. That's the definition of increasing the calculus way. Now, if I plug it in and I get negative, that means that the function is decreasing. You can watch another video on increasing, decreasing that will show you what I mean by this. All right. So if my slope is negative, that means that the function is decreasing. If I plug it in and I get positive, that means that my function is increasing. All right. Now, let's pretend I had this and I plugged in and I get a minus, I get a plus, I get a minus, and I get a plus. Now what I did was I did step number 5 and 6 together. So if I was to ask you on my exam, find me where my intervals are increasing or decreasing, you could actually do the first derivative test, but you would include steps 1 through 6. So if you were to do all these steps here, you're going to be able to find me where the intervals are increasing, decreasing. So the first derivative test has another purpose. Okay? Now, if I was to say sketch the graph for me, that'll be step 7. So wait a minute, that's a different thing that I might ask you on the exam, is give me a rough sketch of my picture. Well, my picture means that if it's negative, that means that my f is going to be going down, then f is going to go back up, then it's going to go back down, and it's going to go back up. So right here we notice I kept going till I got to my critical point. I went till I got to my critical point, and I went to... So this is the picture of f of x. So this is a sketch of f of x. So the third thing that my first derivative test does is it not only helps me find my critical points, not only does it help me find where it's increasing or decreasing, right? So down here I would say is decreasing, here it's increasing, here is decreasing, and here is increasing. That's my second thing. My third thing is it gives me my sketch. So I can do a sketch by using this information. So now that I have that, then I can easily now be able to look at the sketch and state the extrema. So this guy is going to be a relative min, could be an absolute, I don't know, it's got to be lower than this guy. Then this guy could be a relative or an absolute min, I don't know. And then this guy here, he's going to be a relative max. All right. Now he could be absolute, but I don't think so. I think this guy is going to go up further and further. So I'm able to state the extrema by using the first derivative test. The first. So let's see. The first three will find the CPs. The first 6 will help me find what? The increasing, decreasing. If I include number 7, I'm doing the sketch, and number 8, I'm finding the extrema. So by using one test, I can answer all of these questions. So it has 4 different goals, but the main one is to find the extrema. Now, how do you justify it? How do you tell somebody that right here I have a relative min? Well, you're going to say because f prime changes from negative to positive. How do I know that right here, Mr. Quintana, I have a relative, right here, I'm sorry, let's do this one. Right here that I have a relative max. I have a relative max because f prime changes from positive to negative. And these wordings come from the official part right here. At least if it changes from positive to negative, you can have a max. If I have them going from negative to positive, I have a min. Okay, so let's do an example here. All right, so I'm going apply the first derivative to find the 4 things about this function. So here we go. I have an x in this one and I have an x in this one, so that means that I have to do the product rule. So this is my a and b. All right, if you do not know what method I'm using the ABBA rule. So it's going to be a prime b plus b prime a. I've been using this for years. So if you want to, you can look at the video on the product rule. The derivative of a is going to be 2x times my b, e to the x, plus the derivative of e to the x, which is e to the x times x squared minus 3. And I'm going to take this guy and I'm going to set it equal to 0. Okay, so that's going to be my second step. My third step is solve for it. So they both have an e to the x, so e to the x is going to be left with 2x plus x squared minus 3 equals to 0. And here's where a lot of students get confused. They think that this guy will be equal to 0. And e to the x, if I sketch it, e to the x will never ever be 0. Make a note, all right? This guy would never ever equal to 0. So that means that I'm left with x squared plus 2x minus 3. So I'm going to factor that, and I hope it factors x plus 3, x minus 1 is equal to 0. And now I have x equals negative 3 and x equals 1. Oh my gosh, these are my CPs. So I am now able to find my CPs. All right, so I did the first thing. The second is find me where it's increasing or decreasing. All right, so I'm going to draw a number line, and I'm going to put my CPs on there, and please put them in the correct order, negative 3 and 1. Give me a number to the left of negative 3. It doesn't matter what number you pick. Okay, so I'm going to plug in negative 100. All right, and in between negative 3 and 1, I'm going to plug in a 0. And a number greater than 1 that I'm going to plug in, I'm going to plug in the number 10. It doesn't matter which one you pick. Okay, you can plug in 2, a billion, it doesn't matter. Now please, when you take this and you plug it into the derivative, don't plug it in here. It looks complicated. Plug it into the factored form. So I'm going to take it and I'm going to plug it into the factored form. Now e to the something is always positive. So it doesn't matter if I plug in a negative 100, e to the 0 is 1 or 10, it's always going to be positive. So this guy is not important to me. All right. Now, ready? What happens when I plug in a negative here? Negative 100 plus 3 is going to give me a negative value. So let me go ahead and put here, ready? I'm going to plug in e to the negative 100 times negative 100 plus 3, and then negative 100 minus 1. And I don't really care about the value. I care about the sign. So what is my sign going to be? So this guy is going to be positive, this guy is going to be negative, and it's going to be negative. So when I multiply those three, I'm going to end up with a positive. So this is going to be positive. That means that my function is increasing. Now the next thing that I'm going to do is I'm going to take my 0, I'm going to take this 0 and I'm going to plug it in now. So I'm going to get e to the 0, a 0 plus 3, and then 0 minus 1. And that's going to give me positive. That's going to be e to the 0 plus 3 is positive, 0 minus 1 is negative. So when I multiply those three, I'm going to end up with negative. So that means that my function is decreasing. So then I try one more. Let's try 10. So I'm going to get e to the 10 times 10 plus 3 and then 10 minus 1. So that here is going to be positive, that guy is going to be positive, that guy is going to be positive, so that's positive. So that means that it's increasing. Guess what? I found out where my function is increasing or decreasing. So where is it increasing? It's increasing from, okay, so let me state it somewhere over here. It's increasing from negative infinity all the way to negative 3, and it's also increasing from 1 all the way to infinity. Now where is it decreasing? Well, it's decreasing from negative 3 to, oops, that's supposed to be to 1, and I'm done. So that's the second thing that I'm able to find. Remember, I'm supposed to be able to find 4 things. So what if I had asked you to sketch me the picture of f? Well, f is going to go like this. It's going to go up, and it's going to go back down, and it's going to go back up. So right here it starts to go back up. Here, from here to here is going down, and then from negative infinity to this is going up. So this is the way it's going to look. So this is going to be a sketch. It's going to be a very rough sketch. And then finally, the last thing is to state the extrema. Well, by looking at the graph, I can state the extrema. I can say that I have a relative max at x equals negative 3, and I have a relative min at x equals 1. Okay? Now, why do I say negative 3? Because f prime changes from what? From positive to negative, and here it's f prime changes from negative to positive. And again, I apologize for my writing. I'm using this write pad that I've never used before. Okay. Alright, shall we try another one? Sometimes I'm going to be nice to you and I'm going to give you the f prime function rather than the f function. So in here, you don't have to do step 1. So what is step 2? Set it equal to 0. And just by looking at it, you can say that my CPs are going to be at x equals 1 and x equals negative 2. So then the next thing is to draw my number line. Put negative 2 on here, remember? Put them in correct order for the number line. So now what I'm going to do is I'm going to take a number here. So I'm going to try negative 3. I'm going to type in 0 and I'm going to type in 2. So when I plug those into my function here, when I plug in a negative 3 minus 3, minus 3 minus 1, I'm sorry, I made a mistake there. And here I'm going to get negative 3 plus 2 squared. This here is going to be negative, and this is going to be negative, but when I square it, it becomes a positive. And a negative times a positive is negative. That means that my function is decreasing. So it's going to be going down in this interval. So now the next one is I'm going to plug in a 0. So what happens when I plug in a 0? I'm going to get 0 minus 1, and then 0 plus 2 squared. That's going to give me negative. That's going to give me positive. So when I multiply them, I'm still going to get negative. So it's still going to decrease. So in this interval, it's going to decrease. It's still going to go down. All right, then I try the last one. The last one, I'm going to plug in a 2. So I'm going to say 2 minus 1, and then 2 plus 2 squared. So that's going to give me positive and positive. That means that it's going to be positive. So that means that my function is increasing. So that means it's going to go back up. So my function is going to go down. Now, what does this tell me? This tells me that I'm going to have an absolute min at x equals 1. And why? Because f prime changes from what? From negative to positive. And I will test you that on my exam. Okay? Alright, so let's try one more before we end this video. Alright, so I have f of x, so I'm going to take my derivative. F prime of x is going to equal to 45x squared minus 5x to the fourth, set it equal to 0. Now they both have a 5, so I'm going to factor out a 5x squared. When I do that, I'm going to be left with 9 minus x squared equals to 0. And if I factor that, I'm going to be factored 3 minus x and then 3 plus x, the conjugates. So that means that I have x equals 0 is a CP, x equals 3 is another CP, and x equals negative 3 is my third and final critical point. Okay, so here we go. Let's plug in a negative 3, let's plug in a 0, and let's plug in a 3. So I'm going to pick values in between on each interval. I'm going to plug in negative 4, negative 1, 1, and 4. So when I plug it in, I'm going to plug it into this one here. Now this term here is always positive, so I'm not going to worry about that. It's going to be positive for the first one. So it's going to be positive. Here I'm going to go 3 minus a negative 4. That's going to be 3 plus 4, so it's going to be positive. And here I'm going to go 3 plus a negative 4 is going to be negative. So that means that it's going to be negative. That means that it is decreasing. So that means it's going to be going down. All right. So then on the next part, I'm going to plug in a negative 1. So I'm going to end up with a positive. Right here I'm going to get positive. When I go here 3 minus a negative 1, that's going to be positive. And then on this piece here, I'm going to get 3 plus a negative 1 is going to be positive. That means it's positive. That means it is increasing. So on this piece is going to go up to this point. Now let's try the number 1. Okay, so let's try 1. When I plug in a 1, I'm going to end up with positive right here. 3 minus 1 is positive. And 3 plus 1 is positive. So that means that I'm going to end up with positive. Okay, so that means it's positive and it is increasing. So that means it's going to continue going up. And then finally on the last one, I'm going to plug in a 4. So I'm going to end up with positive. 3 minus 4 is negative. 3 plus 4 is positive. That's going to give me negative. That means that it's going to be decreasing. So it's going to go down. So just by looking at this, I'm going to have a relative min here at x equals negative 3, and over here I'm going to have a relative max at x equals 3. Now why do I have a max there? Because f prime changes from what? From positive to negative. And over here f prime changes from negative to positive. Now, for those of you saying, I don't trust you, sir, so I am going to take out my calculator and I am going to go to a new page here, control page, and I'm going to add a graph. And what was my function? Let me go ahead and plug it in here. So I'm going to go 15 x to the power of 3, right? And then it's going to be minus x to the power of 5. So let me go ahead and press enter, and there it is. Okay, so let me maximize this. Right here, do you notice that right here at 0 I have a little flat line? So it's going to go down, it goes up, and then it goes up, and then back down. And this picture does not look like my picture, but you can always make mine go down like this, really nice, and then go back up like this. Makes it flat and continue going up and then down, and now it's going to have a better picture. That's why I like to use the word sketch. Sketch is a really rough draft. Okay, and that is the end of the video.